Let's take a look at the way an economist would describe the market for Uber journeys. We start by drawing two axes. We'll label the vertical axis price. This shows the fare rate that applies at any particular time. Now we need a horizontal axis. We'll label this one quantity. What we're looking at is the quantity or number of rides that are taken at any particular fare rate. Now on this graph we can draw a typical demand curve. You can see that up here in the top left corner, when the price is high, the number of rides is low. Some people are put off by the high price. However, down here in the bottom right hand corner, when the price is low, the number of people wanting to ride is much higher as more people decide they'd like to travel at the lower price. Now let's add a supply curve. Let's look at what's happening here to check it makes sense. Down here in the bottom left corner, where the fare is low, fewer drivers will want to work. Conversely, up here in the top right hand corner, where the fare is high, more drivers will make themselves available. They might make short-term decisions extending their working hours, or they might have learnt from experience the times when surge pricing is in operation and choose to work then. So I hope all that makes sense so far. Now, the key point on this diagram is where the two lines cross. Economists call this the equilibrium. It's called the equilibrium because this is the place where supply equals demand, and that will determine the fare price and the number of rides that passengers will take. We can mark these on the diagram and label them. P1 for the fare rate or price, and Q1 for the number or quantity of rides that are taken. Now imagine that we're reaching that time in the evening when people start to go home from their nights out. Add to that the fact that it's started to rain. No one really wants to walk to the station or stand at the bus stop, so lots of people want to hire an Uber. How do we show that on the graph? Well, the first thing to say is that the demand curve we have is no longer correct. Because of the time of night and the fact that it's raining, at any particular price, there are more people wanting a ride. We show this as a shift in the demand curve outwards to the right. If nothing else changed, this would mean that we had too many passengers for the number of drivers to take. At the current fare rate, demand significantly exceeds supply. But this is where the surge pricing comes in. The Uber system notices that there are too many passengers for the number of drivers to take, and it applies surge pricing. The new pricing is immediately seen by both passengers and drivers, and that causes two things to happen. Firstly, the increased price attracts more drivers. We show this as a move along the supply curve upwards and to the right. At the same time, some potential passengers are put off by the increased price. They decide that maybe the bus home isn't such a bad option. We show this as a move back along the new demand curve we drew. And so we see that what economists call the forces of supply and demand have worked together to bring us to a new equilibrium point. And this gives us a new equilibrium fare rate, P2, and a new equilibrium number of rides, Q2. And that's how Uber surge pricing works. It's also why economists love Uber so much. It provides the perfect example of the theory of supply and demand in practice. And what's more, Uber has all the data, so economists can study it to find out what happens in different situations.